Okay, this is the last test we are going to learn to determine if a series converges or diverges, and it is called the ratio test. The ratio test you will typically use anytime you see factorials or you see things raised to the nth power and it's not a geometric. Okay, that's your clue when to use the ratio test. The ratio test, these are your conclusions. If you take the ratio of the limit of the n plus first term divided by the nth term, and that limit is less than 1, then you can conclude that the series converges. What this really is saying is if you take the next number divided by the previous number and it's less than 1, it really means the numbers are getting smaller. If that ratio is bigger than 1, it really means those numbers are getting bigger, so the series diverges. If it's equal to 1, then this test is inconclusive. But if you typically do this test on series that have factorials or exponentials, it should work most of the time. It does not typically work when you just have polynomials. So I'm going to use the ratio test, and I know right away from looking at this I want to use it because I see factorials and exponentials. So I want to take the limit of, and we're going to do absolute values, the n plus first term. So wherever you see an n, you're going to put an n plus 1 divided by the nth term. And I'm going to go ahead and turn it into a multiplication problem by multiplying by the reciprocal. And then you will need to simplify lots of things here. So first of all, n factorial and n plus 1 factorial. That will simplify to leave you with just an n plus 1 on the bottom. 2 to the n plus 1 and 2 to the n. This 2 to the n plus 1 is really 2 to the n times 2 to the first. So the 2 to the n piece cancels, so you're really just left with the 2. So this is what it simplifies to. Now if I take that limit, this is 0. Ratio test says if you get to a number less than 1, it converges. There's my ratio test. Number 2. Okay, I see lots of exponentials. That is my clue. Exponentials are things raised to the nth power, and this is not a geometric because you also have that n squared. So this is my clue. I want to use the ratio test. So the limit, n goes to infinity of, anywhere you see an n, replace it with an n plus 1. So this becomes n plus 2 there, 3 to the n plus 1. Divide is the same as multiplying by the reciprocal. So here is my setup. Okay, before you start taking this limit, you can simplify lots of things. This n plus 1 squared and this n squared I can't really do anything with yet, so I'm going to leave it. Okay, so that takes care of that. The 2 to the n plus 2, the 2 to the n plus 1, again, this is really 2 to the n times 2 squared. This is 2 to the n times 2 to the first. So the 2 to the n's drop out. 2 squared on the top and 2 to the first on the bottom just leaves you with the 2 on the top. Same idea with this. 3 to the n over 3 to the n plus 1 just leaves you with the 3 to the first on the bottom. Okay, what is this limit? Degree on the top and the bottom is the same, so your ratio of the lead coefficients, so this limit is 2/3. Again, this is less than 1, so I can conclude that this series converges by the ratio test. Okay, last one. So this one, you can, I can use the ratio test if you want. So the ratio test can be used for alternating series because you end up taking the absolute value of it. So let's try the ratio test and see what happens. Negative 1 to the n plus 1, square root of n plus 1 over n plus 2, multiply by the reciprocal. Okay, let's talk about this limit. First of all, nothing's going to cancel right away except this negative 1 to the n piece if you want, but negative 1 to the 1th, when you take the absolute value, is just 1. So notice what's left over. Notice the degree on the top and the bottom is the same. You have a degree of 1/2, 1, degree of 1, 1/2. This limit is 1. Ratio test is inconclusive if it's 1. So I will have to go to a different test. The only test that's available for this one is your alternating series test. But when I look at this problem, you want to know right away that you should go to the alternating series test first because I do not see exponentials. Exponentials are things raised to the nth power, and I don't see factorials. So if you don't see either one of those, that's a clear sign you should not use the ratio test. So I'm going to use the alternating series test instead. So is it true that the limit of the general term is equal to 0? Yes, it is. Degree on the bottom is bigger. Is it true that the n plus first term is less than the nth term? And yes, it is. So it converges by AST.